Okay, we're getting a little closer to being able to put all of this together and be able to be really dangerous when answering questions. So, just before we get to that final piece of the puzzle, we're going to practice some of the things that we have been learning about. And so, in this particular problem, I want you to tell me which quadrant each of these angles lies in, find the reference angle, and then tell me if the expression is positive or negative. And so, I'm going to walk you through these examples one step at a time. And so looking at this angle 3 pi over 4, well, what do I know about my coordinate plane? I know that this is 0 radians, the top of the circle is pi over 2, the left side is pi, and the bottom is 3 pi over 2. And so where does 3/4 fall in here? Well, remember, we go counterclockwise whenever we have a positive angle, and 3/4 is in between 1/2 and 1. And so that's going to put me here into quadrant 2. And so that's the first answer that I'm going to write down, that this is in quadrant 2. Okay, so this is going to represent 3 pi over 4. Now, reference angles, remember, are the angles that go back to the x-axis, to the closest x-axis. So in this particular case, if my angle is here, the closest x-axis is pi. And so my reference angle is going to be right here. It's going to be the difference between pi and 3/4 pi. Well, you can think of pi as being 4/4, and so the difference between 4/4 and 3/4 is going to be 1/4 of a pi. And so the reference angle is going to be pi divided by 4. Now let me let you in on a very important trick. Here it is. For radians, this is what makes radians a little easier than degrees. It's why I'm a little faster at doing things in radians than I am in degrees. Here's the trick. To find the reference angle, all you really have to do when it's in radians is look at the denominator. So the fact that the denominator here is a 4 tells me pretty much automatically that the reference angle is going to be pi over 4. That is a beautiful shortcut. It's going to make your life a lot easier whenever you're trying to find these values in a fast, quick way. Okay, finally, the last thing we want to do is tell whether or not this expression, sine of 3 pi over 4, is positive or negative. And so here's what I know from the previous discussion. All students trust Castle. And so in quadrant 2, sine of any angle that is in quadrant 2 is going to be positive. And so therefore, since this is sine of an angle in quadrant 2, we know that this result is going to be positive. If it said cosine of 3 pi over 4, then that would be negative. If it said tangent of 3 pi over 4, that would be negative. But because it says sine, and sine is positive in quadrant 2, then sine of 3 pi over 4 must be a positive answer. Okay, here in letter B, we're going to do pretty much the same idea here. So looking at 4 pi over 3, figuring out what quadrant that is in. And so here's a good trick. 4/3 pi is really the same as 1 and 1/3 pi. And so when I draw my coordinate plane here with 0, pi over 2, pi, and 3 pi over 2, 1 pi is going to put me all the way onto the negative x-axis. Now, to go another 1/3 of a pi, remember 3 pi over 2 is really 1.5 pi. Well, 1/3 of a pi is smaller than 1/2 of a pi. And so therefore, this is not going to shoot me past the negative y-axis. It's going to put me into quadrant 3. Okay, the next thing we want to know is, what is the reference angle? Well, the reference angle is the shortest way back to the x-axis, and so if this is 4 pi over 3, you can think of this as being 3 pi over 3, and so the difference there is 1 pi over 3. But again, radians are so easy because all you have to do to find the reference angle is just look at the denominator. Okay, finally, what is this going to be, positive or negative? Well, all students trust Castle, and so because this is in quadrant 3 and it's cosine in quadrant 3 is negative. The only trig function in quadrant 3 that would be positive would be tangent, and so because this is cosine, the answer to cosine of 4 pi over 3 must be negative. Okay, here on letter C, we have the angle 5 pi over 3. So again, taking this mixed fraction approach, 3 goes into 5 once with 2 left over. So 1 2/3 pi. Well, here's 0. This is half of a pi. This is 1 full pi. And here's 1 1/2 pi, which is how you can think of 3 pi over 2. And so 1 pi is going to get me onto that negative x-axis, and then if I go another 2/3, that's bigger than 1/2, and so this is going to shoot me past that negative y-axis into quadrant 4, and so this angle is in quadrant 4. The reference angle is the small angle that goes back to the x-axis, and that x-axis needs to be thought of as 2 pi in this particular case, or as 6 pi over 3. And so if this angle right here is 5 pi over 3, then the difference between 5 pi over 3 and 6 pi over 3 is 1 pi over 3. But now for the third time, as I've told you, radians are super easy to find the reference angle because all you have to do is look for that denominator. Finally, is this going to be positive or negative? Well, all students trust Castle, and so this is a quadrant 4 angle. This is tangent of a quadrant 4 angle, and the only function that's positive in quadrant 4 is cosine, and so that means that tangent of 5 pi over 3 is going to have to be negative. Okay, last preliminary example here before we put everything together and try to answer some questions. So tell which quadrant each angle is in, find the reference angle, tell if the expression is positive or negative. So the first thing is 7 over 6 is really the same thing as 1 1/6 of a pi. And so if this is 0 and pi over 2 and pi and 3 pi over 2, then 1 is going to get me here, and then 1/6 is going to be smaller than 1/2. And so this is going to put me into quadrant 3 right here. The reference angle, all I have to do for radians is look at the denominator. And so because this is over 6, I know the reference angle is going to be pi over 6. And then finally, is it positive or negative? Well, to figure that out, I need to remember this acronym. All students trust Castle, and this is in quadrant 3, and it is sine, and the only function in quadrant 3 that's positive is tangent, and so therefore sine of a quadrant 3 angle must be negative.